Okay, so if you're not in class with us, I'm going to start with a few easier videos that don't have, that just have maybe one equation with them. That way you can kind of get the idea. Now, when we go to do something, we go to graph something like this. This is section 4.10. This is number 1. What I need to do is think a minute. If you get confused, think a minute. What would we do if this was y equal 3x plus 1? We're going to go ahead and graph it as if that's the case, but we're not going to connect the dots because the less than sign means we need to think about a few things. But we're going to act as if this is the graph for just a second of 3x plus 1, and we're going to at least plot the points that are on it, okay? Since this is in y equal mx plus b form, the 1 on the end is my y-intercept. So I'll go plot that first. Remember, because we got to when we plot lines, we have to have some place to start, and then we find that starting place, whether it's the y-intercept or a different point that we're given, and then we count the slope off. Well, our slope is 3, and I want to rise over run, so I'm going to make it 3 over 1. So we rise 3, and we run 1. That would put a point about here. We could go ahead and put some more points in, rise 3, run 1. It doesn't matter where we count from as long as we're on the line. So we can keep counting, and we can fill up our whole a graph here if we wanted to. Remember, if I wanted points below my starting point, I could think of a positive 3 is the same thing as a negative divided by negative, so I could count my rise down 3 for negative 3 and my run left 1 for negative 1. So that's what I'm doing here is I'm going down 3, left 1, because negative 3 over negative 1 is still equal to 3. So that's how I can get some dots. Now, I don't want to connect those dots because if you look at this equation, it's y is less than. If it had a less than and equal on it, I would draw a solid line, but there's no line under that less than sign. So what that means is all my solutions are below the line 3x plus 1. Now, if you look at it, what that means is I don't have any on the line. There's no equal sign under that less than sign. So again, I can't put a ruler to draw a straight line. That's about the best I can do free-handed. So I don't have any solutions on the line because there was no equal sign. If it had been less than or equal to, that means include the points on the line as solutions. But we just want the points that are below the line, or we want points that make this equation true. A less than usually means your y is less than this expression means the thing's below the line. So one thing I could do is if I'm looking at the line, below the line would be like right here. So I could shade in. Usually we don't shade the whole thing solid, but you're welcome to if you want to. Another way I can see if I shaded the right point, now this is, the less than 3x plus 1 has kind of come about, people doing it the way I just explained it because of the graphing calculator, but one way I can tell where the solutions are also, because I'm going to shade on one side or the other. Which side is it? The old school way of doing this is to pick a point that's clearly on one side or the other. So let's say I had picked the point 1, 1. It was right in here. It's clearly on, not on the line. And I could plug it in. Is 1, so I've got the point 1, 1. X is 1, Y is 1. Gosh, okay. So if I plug in y is 1, is 1 less than 3 times 1 plus 1? I sure wish the iPad would pick up my finger strokes here. 3 times 1 is 3, plus 1 is 4. Is 1 less than 4? Yes. So the point that I chose is definitely where the solutions are. It works in the equation. That's why we shaded over here where we did. A lot of times what we do is we just draw a few lines like this, because in a minute we're going to have two equations that are going to overlap. So we're going to either need to draw our lines where we can tell where things are overlapping, or we could use colors. It's kind of easy here on the iPad to use colors, but if you're going to use colors, graphing yourself, you might want to have some matte pencils or some highlighters handy in this section. So I'm going to do another one now. Let me get another graph up there. Okay. So I'm going to look at, we're doing 1 through 16 all. Let's go ahead and just do number, I'll go ahead and pick one that has 2. Now, the problem with this, I'm going to probably have to write over this graph and then graph it on another page because I'm probably not going to have room. If I choose number 3 to do, I have to graph that line. And graphing that line is means that I'm going to have to put it in a form that's easy to graph. So again, this is number 3. 2x plus 3y greater than or equal to x. And then the other equation, I'm just going to write it over here in a separate column, is 2x minus y less than 7. In order to graph these, I'm probably going to need to go ahead and solve for y. So let's do that. And then my first equation, I'll solve for y by moving 2x to the other side, by subtracting it. Remember, Lazy Math Guy doesn't write that plus out front, but you could put it on there because 2x plus 3y is the same thing as 3y plus 2x. So if you wrote it in a different order, you'd be able to see there, you could think of that as having a plus in front of it. All right, I'd have 3y is greater than equal negative 2x plus 6. And so that's going to be y. When I divide everything by 3, I'm going to get negative 2 over 3x. Now remember, you also have to divide the constant on the end, and some of you forget that sometimes, so just want to remind you, you got to do that. Y is greater than or equal to negative 2/3 x plus 2. Okay, I'm going to have to remember that equation because I'm going to have to graph it, and we'll have to go to another page to do that. Let me come over here and solve the other one. If I want to get y by itself, I'll subtract 2x from both sides. Now here we're going to see something that we've got to be careful about happen. When I cross those out, what I have left is 0 minus y, which is negative y, is less than negative 2x plus 7. Okay? Now, if I want to get y by itself, I need to, it's like got a negative 1 times the y. One way I can do that is to divide everything by negative 1. But do you remember, with inequalities, there's something you got to be careful about. And that is that if you ever divide or multiply by a negative number, when you do it, you need to change the direction of the inequality sign. So what I end up here with is y is greater than a negative 2 divided by negative 1 is a positive 2x, and a positive 7 divided by negative 1 is a negative 7. So y is greater than or equal to negative 2/3 x plus 2, and y is greater than 2x minus 7. Okay, so now it's time to graph the easiest. We first had to solve the equation. All right, so I'm going to graph the top one. I'll choose blue for the top one. So my y-intercept here is 2, and I'm going to count my slope down, negative 2/3. Rise is negative 2. That means go down 2. Run is a positive 3. Remember, we only put the negative with the top or the bottom, not both. If I run over 3, that's going to be 3 to the right. That's going to put me here, okay? Now, just for the sake of time, I'm not going to fill this up. When I go to draw this line here, I started to make a dotted line, but I was wrong when I did that because look right here. Well, I covered it up, but underneath that greater than sign was an equal sign. That means there are going to be solutions to this equation could be on the line, so I'm going to actually draw a solid line. You draw a solid line when you have that equal sign underneath it. Now I'm going to go graph the second one, and I'll graph it in green, a lighter green. There is no equal sign under this, so it's just y greater than 2x plus 7. Actually, before I do that, I forgot to do my shading on the top part. Sorry. Let's go back to the first equation. Greater than or equal to negative 2/3 x plus 7. We want the y's that are above the line, because greater than means bigger than, or above the line is how we could translate that. We could also pick a test point, and plug it in to see where to shade like I did on the first problem. Greater than the line is going to be above the line. Oops, let me go back and change back to that blue. So here's what we usually do when we got two equations. We're going to draw some lines. I'm just going to kind of try to make them look perpendicular to that blue line. You know, that might help to turn your page sideways until you get used to doing this. And if I extended that line on up, you know, it would also be up here, wouldn't it? Now, if I go to graph the bottom line, I got to do the same things with it. I had commented on the fact that there is no equal sign under that greater than sign, so we're not going to draw a solid line in this case, but I still need to graph it. The y-intercept is this 7 here. 7 is right here, okay? And the slope is 2. So I want to make that 2 over 1. That means rise 1, run 2. Rise 1, run 2. Rise 2, run 1. Rise 2, run 1. And then I could make it negative 2 over negative 1 to get points on the other side of that dot. So down 2 to the left 1, down 2 to the left 1. I can see what's going to happen here. So let me just go ahead and kind of free sketch the line in. And again, it's not a solid line because there was not an equal sign under the inequality. Now I want the y's that are bigger than 2x plus 7. Remember, 2x plus 7 represents the line. Where the y is bigger than the line, they are above the line. So I'm going to shade like this. And again, you could color it in solid, but it takes a whole lot longer to do that. Oops, don't want to go past my line. I almost did. I'm going to kind of draw maybe a few more lines in so we can kind of see. Now, what we're looking for is where do the two graphs intersect? Where do they cross? And because I'm using color here, I could say, where do I see both colors? Okay, that part of the graph is the solution part. Another way I could do it is if I'm drawing my lines like this, let's say I just wanted to graph in a pencil, that's all I had, and I was trying to solve, and all I had was a pencil available. Well, you can also tell where the solutions are by where you see these kind of diamond shapes created. I'm going to color over with yellow the solution sets here. Where I see both of them are, both colors are in here. I'm going to try to draw that solid. Usually when we're doing showing our solutions, we draw that in solid. It's only where those are overlapping, okay? So it would be right here are my solution sets. If I pick any point out of this area here that's a triangle, any point out of that triangle would work in the graph.